Hey, welcome back. And as promised, I'm not going to lecture. We're going to do some plots. But before I get started, something very important. So the two administrative folks who are making all this organization run so smoothly are Socorro and Melissa. And unfortunately, Socorro is sick and will be out the rest of the week. But we did want to thank her because she was instrumental in setting things up, and she's working from home, but she's still making things happen. So I've got a card for her. Please use both the front and the back. And but if you'd sign it, we'll make sure she gets that to her. But we'll give this, at the end. But just if you want to thank her for all the organization, things like that. So I'll start that around, and if you'd go ahead and fill that out. So what we're going to do is primarily Python, but I've got a couple options. And let me find out where I left it. Okay, so on the Indigo, there's a few things. So the exercises, those are some plots that I want you to make in the next hour or so. And we're going to be working with the Python Jupyter Lab. Everything is inside the virtual box. So if you are inside the virtual box, everything will work beautifully. That's fine. If you want to work outside the virtual box, all you need is Python Jupyter Lab and the LHA PDF libraries, which you can install. So this will be the main project. But if you are a fan of Mathematica, like I am, MainParse is a Mathematica program that allows you to read the grids. And you can download and try that. And if there are any questions, that I can take that. So that's sort of optional. There's a link here to the interface. There's a package. You just download it and comes self-contained with all the PDFs. And the manual is here. And then very briefly, the TMD, Transverse Momentum Dependent PDF Plotter, is a product out of Daisy. And there are a few examples in the PDF there. The paper is here and the link is there. And so if you want to take a look, if you're interested in that, that just gives you a way to look at some of those things. So let me just start off by showing you what I'm looking for you to do. And ideally, we'd like to be able to do about 4 plots. So the most basic one is just to take the PDFs and plot them as a function of X. And so you can see I've got the gluon going off scale, so it's convenient. It's common to divide that by 10 to keep it on scale. But we just want to be able to manipulate these PDFs. We generated them on Thursday and dumped them out in the file, and it's just we want to do that. So we plot them by X, we plot them by Q, and then I want to do a simple integration, and we're just going to do the momentum fraction. And one of the sanity checks you can run, if the PDF grids that you're working with are reasonable, you should be able to add up all the flavors, and the momentum fraction should add up to 100. And so here is a plot of some samples, and you see if I add up, the gluon is about 40%, the up is 30%, the down is half that, because there are 2 ups for every down in the proton. And if you add it all up, you get about 100%. So we just want to do that with our PDFs. And then the last one, once you start doing integrations, it's sort of interesting to look at the momentum fraction as a function of Q. And so what you can see here is the top is the gluon. So the gluon is about 50%, and this is the up and down. And anybody know what this guy is out here? It turns on, that's in Q. So that's Q, scale of 100 JeV, 10 JeV, 100 JeV, 1000 JeV. What turns on somewhere after 100 GeV? Go ahead. All right. Nope. So what's it? Yeah.
Top quark.
Top quark. Yeah. So there's the top quark. What's the mass of the top quark?
100.
Okay. What could this be? This is 10. That's 1. What's that guy? Say louder.
참고.
Charm is here, bottom's here. What's the bottom mass? About 4.5 to 5. Charm cork, about 1.5. Okay. And so you can actually see them turn on. And as you go out asymptotic at a high energy, you start getting a flavor democracy. So it's a nice cross check. And again, one of the first things I do when I get a PDF set, I just add up the momentum fraction, make sure I get 100%. It tells me if I goofed the program or if there's a problem in the grid file, just a sanity check there. So that's what we're going to do. So let me go into the virtual box. And then again, last time we made some, just go away. My video. Bishop. Okay. So let's see. So last time what we did was we made some PDF sets, and I have some standard ones off the web, but we ran a RS fixed and an RS free set. We were looking at what happens when I fix the strange to be half the up and down, and then I allowed it to be free. And if I just open that up in a new window, okay, these are the actual PDF sets that xFitter dumped out. And there's an info file that just has basic things like it tells you what, it tells you the parameters. And then this is just the raw data file. And then, we really don't want to look at that, but we want something that eats that. And so LHA PDF will do that. And so let me start from scratch here. And so if you go ahead and open up a blank xFitter window, if you go into the Python area, and here's this read LHA PDF notebook. And if you open that, that will open up Jupyter Lab into the Firefox, and you should be set to go. And inside here, I've installed the LHA PDF library. That's a C program that you can use for interfacing the PDFs through C program, but also has some Python wrappers that I'm using to talk to the PDFs. And I'm just going to go and run this whole thing, run all cells, and what that does. So the key steps here are that where's my LHA PDF? Yeah, right here. So I import the LHA PDF library. Okay, and in this case, I've had to tweak it a little bit. I had to point to where it was, so I got a specific version, but you can check there. And then you can look at the paths and things like that, very system things. And then if you using the operating system things, you can look at what PDFs are in the directory. And so there's a whole bunch. Here's the NN PDF that Stefano talked about. Here's NCTech that I worked with. There's MSHT. There's HERA, a variety. But the two we want to focus on are RS free and RS fixed, because one of those had a small strange, the other had a large strange. And so this is just these are just examples of how you can sort of talk to it and get the variables. But the key step is right here, down here, the functions in PDF. And this step right here, what I'm going to do before I do the RS fix, I'll just show a demonstration with the NCTech. So I use LHA PDF get PDF set, and I tell it to go get this set. Oops, that. And then this will make all the PDFs in the set. In this case, there's only one. I could look at the length of that and find that out. And once I make that, then what I can do is this object evaluates the PDF. And so in here, I have, this is the 0 is the central set. If there's error sets, that could be higher. And this tells me I want parton 2 at x of 0.1 and q of 1.0. And in the notes, there's a set of notes attached to the web. Let's see, instructions. up here, oh, yeah, it's right here. So there's some notation. There's some notation about this. But that is the key step right there because that pulls the PDF. And now you have a true PDF function. And you have all the flavors at any value of X and Q. So let's do the RS fixed is one of the ones we want. And that comes out here. You see that's loaded and I get a value. And then I'll do the same for RS free and I get a value. Okay. And at that point, you have a function that'll evaluate any PDF that you want. And there's some more examples down here, but let's make some plots. And here I'm just making some very simple plots. You see how I do that. If you can probably do neater Python than I did, but these are just some samples. And then if I go down further, I'm going to define. I can do some comparisons. In this case, looking at lead and iron from a PDF. I can look at the uncertainties for the ones that have air bands, and I can draw air bands. But then the other thing we want to be able to do is we want to be able to integrate. And for right now, we're just going to get the momentum fraction because that's simple. But once you know how to integrate, a cross section is just a convolution of a PDF with a cross section, with a Partonic cross section. And linear order, that's just a function. So once you can integrate, you can go from a PDF to any observable. And so we're just going to do that. I'm going to use SciPy for my integration, and I'll just use a Simpson. So I'll just give a bunch of points. And if I scroll down a little bit, I've got that right here. And so right here, this is the SINT0. I'm going to integrate the strange quark for the fixed set. Okay, and then I'll do the same for D bar and U bar. And then I'll construct the ratio 2 strange over D bar plus U bar. And lo and behold, that comes out to be about 0.5. I'm looking at this at Q 1.4. And then we do the same thing for the free set. Okay, and that turns out to be about 1.1. Okay, and that's what we saw before. If I force the strange to be half the U bar D bar, this ratio comes out to be 0.5. If I let it float and let the data drive it, particularly the Atlas WZ inclusive data, it seems to push it up in excess of 1. And that was a very surprising result in 2012 when this analysis was done. So that's the basics. You can do it in any form you want, but the goal is to, if you're weak in Python, work with your neighbor to do that. Let me very briefly show you the Mathematica options. So, and again, I'm partial to this because, before there were Jupyter notebooks, there was Mathematica. So if you go to the web, you'll find on HepForge, main parse is a Mathematica interface for pulling with those same grids. So main parse, it's at SMU, our mascot is the Mustang pony. So that's sort of a play on our mascot, but that's where the name comes from. But if you download this PDF demo, it's very small and it includes the grid files you need. If you download that and run that, here's the output of that, and that will do things like it will load everything and get you to the PDF. So if I scroll down a ways, here's some plots. Here's an alpha S plot. I can look at the functions. I can look at it versus X and Q. That's where I stole things. I can make 3D plots and take a look at that. I can look at the pointwise and make other fancy ones. So it's very flexible. There's also a few other demonstrations there. If you want something a little bit more detailed, let's see, this gives you a longer, more complex version. But if you want to work in Mathematica, that's another way to use it. So that's the project. We basically want you to go back to the examples. The exercises. So basically, we're looking for you to just go ahead and make these. So just go ahead and make these plots as the goal. And that's sort of the end of my discussion, and go to it. If you have questions, I'll be around to help. But if you can do this, you can last week we learned how to generate PDFs using fitting. Now you can manipulate them. You can now integrate them to look at momentum fractions, cross sections, and you got everything you need. So that's it. And good luck. If you have any questions, I'll be around.
So. Didn't understand.
You want to do the mathematical one? Okay, so here, just go ahead and second.
Yeah.
And so let's download.
Trying to get,
All right. So let's look at it. So you downloaded that.
I guess.
Is it?
Trying to do.
Yes. Okay, it's what's getting there.
Okay, I can already see all the code there. Yeah, I don't really know. It's one of the other experts.
And this PDF value. And just run into it in.
Oh.
Okay. Well, yes, well, let's see if it works. I'm curious, can you just go to, let's see, evaluation. No, evaluate new. Okay. And it's still running. Scroll down. Yeah, so there's, so, and now you can come in here, is it finished? Yeah. So that's Q. 10, let's do 100. Okay. Yeah, and then, next.
Oh.
So I'm evaluating these, papers. So, as I said, you should. She's got this. So. So let's we'll make a table of ones. Let's see. Let's see, so it's so it's minus 65, so it's 7 value, right?
Hey. Sounds right.
Then if I did this right. Oh, it's the last. What's the last one? So what I did is I made a vector. I made the last element a 10th. That, since the glue on is at the end, then I just scaled it down. And so just be fancy. And this here it is versus Q. And here are the 3D plots. Oh, it's one word. That I feeling that word.
I'll just leave it like bottom.
Yeah, so now you've got everything you need to.
Negative.
I have it. I use it.
Got everything you need.
I use it. Just go there.
Yeah. Yeah, so mathematics is sort of done for you already. PDF, yeah, there's a PDF function. What I did was the package defines a PDF function. And that way. Yeah, so PDF function is what's defined by the program. That way, it's kind of handy. You can redefine a just lowercase PDF. And that's what I did. And that's sort of nice because if I define PDF, you don't want to copy my definition. So I'm gonna make it the same, but you could do, some error checking or boundary or something like that. So.
What are the? Is it 0 for the gluon and then just 1 for 6?
Yeah, right. So, yeah, so that's the 3 is a strange, 4 is a charm, 5 is a
Okay, so it's up, down.
It's down. Yeah, it's
Down, up,
it's
strange,
yes.
charm.
Yeah, tennis is to say up, down, and that's the old system.
Yeah,
But if you go down, up, then it goes negative, positive, negative, positive.
so it down, up, strange, charm, bottoms up.
Down, up, strange, charm, bottom, top. And then negatives for the top. And then the gluon, Monte Carlo convention is 21, but we allow it to take either 20. Pretty sure, the mathematics, pretty sure, sorry,
0.
or 0.
I'll be 20.
Yeah.
So, but, so down is 1.
Down is 1. Yeah, that's, yeah, for a decade, I did it the other way.
Thank you. Yeah.
So should, I mean, we worked on hers, so hopefully when you get on one with that, you should be able to just download it. All right. Yeah, okay, going to do our. Okay. So, if you want, you can scale the glue on. Well, all right. Well, let's come up, get a new cell up there. Let's get a new cell.
Okay.
So let's make a table. All right, let's go. Table of 1 comma I equals 1 to 11. 1 comma sorry, curly braces, lowercase, curly braces, I comma 1 term of 11. Turn, execute. Okay, so you just made a vector which is 11 units long. And now let's type flavors. Type flavors. Right where just have flavors.
Yeah.
Execute. Okay. So you see the cool one is the last one.
Yeah.
That's one we want to scale by 10. Okay, so we want to multiply everything by 1 and that by 10. So what we're going to do is let's call this lowercase tab. Say TAB. TAB equals. Okay, execute. Right. And now we're gonna override it, so right there, say TAB. Double bracket, double square brackets.
Yeah.
Yeah, 11. And that equals 110, equals 1/10. Yeah, and then let's. Do that, and then take the tab, TAB return, execute. Okay, so what we see what we've done. Now let's go and we're gonna multiply that there. So it's in front of the X, let's put a TAB. Space, yep. You don't need that. Yeah, the space, yeah.
The space
You
is
need the
like-
space, yeah. Okay, execute that. And see, we brought the one down. Yeah.
Yeah.
So that's, yeah, and because mathematics naturally works with lists, it's kind of, once you get things in a list format, it's easy.
Okay. For example, to get data, I should just create like a grid or something
Sorry?
to do the interval.
Yeah, so you can do an integrate. Now, of course, you can't go down to zero, so you'll have to put a finite X min, but
Actual interval.
Yeah. right. Yeah, so you'll want to do a numerical integral as a function of flavor. Yeah. So you're in the virtual box.
Yeah, that's right.
Okay, is that behaving for you?
Excuse me.
Is that working?
So far I'm still getting the hang of it.
Okay.
Signing.
Let's see, so let's see, you're in the virtual box or you're at BNL. Right, so the catch is you'll need the OHA PDF reference.
Like I mean.
You have that on here? Okay. I mean, if you can compile and install those, you can install them locally. If you don't have root access, you can install locally, and then you just have to point to them. But if you can download, I think I'm running. If you can download that and so you'll configure prefix equals your local installation, or if that works, and then you can point on to it. So you can import OHA PDF, the rest should be.
I'll try.
Yeah.
I'm just downloaded by
Okay.
It's very easy. I'm trying to just integrate.
Now, yeah, so these grids.
Should I use an integrate?
Yes, can I sit for a minute? Let's see, so. PDF question mark. Question mark PDF star. That will give you all the. Question mark PDF star will tell me all the things, and then PDF get info. So if we do PDF get info of set 1, then we do that in table form. Okay, that lists everything in that info directory. And right, and in particular, you see X min is shucks. Yeah, so let's go PDF get info 1. And this is a rule list, X Oh, okay, yeah. So, yeah, so it's. So I probably need quotes. There we go. Yeah, and now I want to see that as. Yeah, so basically 5, 10 minus 6 is the limit. So if we come up here, right, so. So if we come up here and. Let's see, so I'll basically add X min equals 5 times 10 to the 6. So that we X min. And then we actually, we only want, yeah, no, the PDF is the PDF.
I thought it was like.
Internally, the grids are X times the PDF, but in this program, I divide it out. Now, there's another function, there's a function PDF function. And PDF function, yeah, PDF function, and then there's function X. So, PDF function X pulls out X times the PDF. That actually that actually interprets the actual grid and doesn't divide out X. Yeah, but, yeah, I guess we could. Well, let's do it this way. So flavors, so this. Let's see.
It's already a vector.
And it gives a vector. So all right, let's see if we get. So vector equals that, and let's do a plus.
Destroy LH.
Okay.
Yeah, that's why.
Do you destroy?
Oh, okay, yeah. Oh, that
Oh,
also.
oh, the glue, something's wrong there.
So it has all this.
Okay. Let's look at the set. This display.
Like this. What about?
Yeah, there's something wrong there. It's, have you rescaled the?
I didn't touch it.
Yeah. Okay. Let me restart the kernel.
Yeah, maybe I did not. Do it, so maybe I. Okay, so.
I'm still getting garbage. Let's
Fine, time is not bad.
Yeah, but that's like.
Or they with the number of
Yeah, okay, I see.
and not counting the NP.
Okay, let's try a different set. Still.
Just what it learn it and.
Let's do this one. A fraction.
आपने developer generator का change वो generator से आ गया
I mean, he's not like one of them, right? Otherwise it should be,
like
but here's the counting. Also, it's not, wait, what? Sets. Okay, I guess we have to read the code. Yes, I'll read the code. Then wait, what?
Zero.
The thing is, I don't know which one. It's the same one as the Bible.
Yeah, so apparently it wasn't, it wasn't threading that list correctly for some reason. Table. Table.
Here they're not putting up them. They're just putting, maybe it's not. Maybe it's hidden for all.
Oops, maybe it's 6.
No labels. Look, like in this part, it's only plotted up, down, and the up, down, and then strange for bottom, strange on bottom. Oops. In this data set is top.
Oh, wait.
No bottom.
Yeah, so apparently there was something funky that would, well, I just, yeah, I think what happened is it has to thread flavors. It has to thread the
We just
flavors.
plot like
and
the
or
up,
something like that.
down.
Let me just do one thing, to make sure this is 3.0. No, there's something wacky about that. Okay. Yeah. Okay, thank you.
What? Like, yeah, no, but then probably it doesn't go on, and then that just has of so much of the artifact. It's just like, if I were to look at the data, would it actually show this, or is?
Because I have discrete points and probably at some point it drops to 0. Yeah. So, yeah. And,
This.
yeah, and if you look at,
Because I'm charging. Just.
you need USB-C or.
No, it's. So you just.
Yeah, so, so if you look in the info file, you actually see Xmin, Xmax, Q, X.
Oh, okay, I'm
Yes,
just.
the values.
Ballpark.
Yeah. So basically these are starting from 0. They start from 0, basically the mass value. And then ball.
That I need a scale with them.
Yeah. In Mathematica, we made a vector and then made one of the elements 1/10. I don't know how to do it.
I'm doing, I have a 2D array, so I'm just saying. I take what I want. Here, this one, I take what I want for whatever X and then for each flavor, so I index by the flavor and then I'm gonna do if the flavor number equals 21, no, if it's 21, then I divide by 10. And then else, I just take this. Like that.
No, on my.
It's terrible, but
My Python's
I love. the
weaker than,
combinations.
I'm getting better, but it's still my mathematics stronger.
Yeah, my math. It should be good. Really good.
Oh, nice. We don't, and this is the top part that a lot of the sets don't have it. So, yeah, it just, if it's not there, it'll be 0. So if it's not in the set, it'll set it on 0. I think the only one that will have it is that, I think that, let's open it up, real quick. I'll open the info. We look at the info, see those 5, so they don't. There are some that have top forks, but a lot of them don't. Because, it only turns on 175, and unless you're going way above 1,000 gems, it's not gonna make that. So they don't waste the space on it. Yeah, there are some 6 flavors you can download. I can't remember what I use for that. Sure. So you're the Mathematica.
Yeah, I'm just trying
That,
to.
is that behaving? Okay.
That's what is the data service? That's depending on the address.
Yeah. I mean, that's, I did a bunch of them, but if, just, if you can just, so,
Yeah, because I already did that.
oh, okay, good.
But
Oh, yeah, there's a problem.
no,
Yeah, you can't, the list doesn't do it right. So you have to do it one at a time. So let's go back to that line.
Yeah.
Can I sit for a moment?
Yeah.
So what I'm gonna do, yeah, there's something flaky about the way it's threading the list. So what I'm gonna do is I'll take this and I'll. Okay, and so what I recommend, let's see, so PDF, well, first of all, I need an exit area. Oh, that worked. It worked for you, it didn't work. Okay, that's interesting. All right, that worked. Okay. So let's do this. Okay, so, minor thing, but, in Mathematica, all system functions are capitalized. And so if you use lowercase, you want to click, but I'll just go with it right now. So we'll take plus,
Wait, what?
and apply that to INTS. And 6, yeah. And so we evaluate flavors.
Okay. This is, I did this one last time.
5, okay, yeah, so the goal one has 42%. And here's the, let's see. So bottom chart straight, up, down, up and down are pretty close for it. And then
just
down, up. See, so the down is, the up is twice the down. So, this is 26%, 13%. That's about 40%, that's about 40%. So up, down, and blue one is 80%. And everything else shares the 20%. We do this, I'll do this 3, which is closer to the initial value. Okay.
In the Python section.
Change that. Not trivial. And that, yeah, so at the initial value, it's closer. And then, as you evolve up, you could have some rounders and stuff. So we got 90, there we got 99.7%. And we had, I forget what it was. But okay, yeah,
yeah.
great. Yeah, so that's your scale. Yeah. This is
You get some problem.
the X value, we have, and my notation is 0 to imply that Q is fixed. So we're gonna plot it versus X. And later on. Yeah, later on. Okay, I have X0 and I vary Q. So that's. Right,
This is a great idea.
X0 is set to a specific value. And then I'm gonna plot
Q is
Q,
very-
Q is gonna go from
200.
2 to 100.
What?
And up here, Q0, let's scroll up. Q0, I said. Oh, that's the scale that I'm evaluating. So, because you can see. Yeah, let's go T up.
So like,
No.
this is like.
So here, for example,
Here, you have like a new interaction.
so the,
What else? To gamma, I guess, when you only have one. And what is F gamma Z? What's this like two? Because it's a neutral gamma, it's just these two.
so that's the energy scale. So this is the bottom of the
They're like,
This is the charm.
Right?
Basically, when I
You're bad asking people like,
say at a very low scale.
it's like asking
yeah,
them, how do you
I don't
calculate?
see any
plus-
charm because I'm.
Maybe, I don't know, maybe it's not as that intuitive.
Use it a resolution. of one, yeah. But the charm period is everywhere.
It's that intuitive.
Charm period.
But I couldn't find any.
Certainly can't be outliers. It's like,
I did
as I
find
approach
something.
closer and closer, is what happens.
Maybe.
Yeah, the gluon comes along.
No,
The
no.
gluon can always make charm pairs, bottom pairs, top pairs. Top pairs are so heavy that they make a top pair and wait for a second, they were not, because you have to satisfy the certain lines.
Yeah, the
The bottom, it goes a little bit farther,
So it's not
and the charm a little bit farther. And so basically, as I look at closer and closer resolution, now I start to see the charm pairs.
No, no, no.
I'm looking at a smaller scale, I can see the gluon goes. Later, if I get closer, I can see it go like a BB bomb. If I really crank it up over 200, you can see go to TC bomb. And then the gluon is up here, and you see. One is down, two is down, so you can see up, down. Up is bigger than down. And I think so that's what's going on.
Gamma Z and Z, they are like, this is a different term.
Were you able to, were you able to catch all that?
이게 시간 많을 거 아니에요. 근데 굳이 그런 시간
So then if I'm looking at
하나 다 찍었잖아요. 그거 하나 앞으로 왼쪽에 뽑아주면 돼. 있을 때 잘
Can I sit?
그렇죠. 이거 보고 이렇게 찍는 거는 이걸 너무 봤을 때 좀 나중에 하나가 레퍼런스 포인트 찍어가지고 그게 시간
Alright, so let's,
because like this is what I know, right? Hold on. Let me go back to my study.
so what directory it's in the OHA?
We always talk about F2, just the F2, we always talk about. Looking for an age.
So let me, no, what we're gonna do is we're gonna configure and.
Like the level reaction. I mean. Wow.
So,
I thought like.
well, no, you have to put it right. So what I'm gonna do, let me get, can I make a new terminal? Can I make a second terminal? Because, so what I'm gonna do. Top.
Yeah, I know that.
Right, okay, so what I'm gonna do, can I make these make so that'll be like optional stuff, and then you look at that. So what I'm gonna do is I'm gonna configure. Oops. Slash
Worry that it might not work, so mine is only
figure and minus pre fix.
do not see that.
So slash U S here it is slash 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 T. And so I'm going to configure it and tell it to install it in that area. Okay. So we'll see how this works.
You have to already punch it in here and then just. That's the problem is that I don't have. So, you don't have another.
Ah,
If you want to have-
Right. So it seems, well, it's checking. We're gonna configure, make it install. Seems to be finding most of the things. Okay, so I found an old Python, but I think.
I was also. Yeah, there is no such a.
I just like, how do you find this?
Or so.
It took me so long from just someone's exercise.
So take J. Can I do minus J?
Yeah, of course.
Sometimes
But this is
if I
if you're-
use too many of mine, it kind of blocks things up.
Okay.
We don't care about warnings.
I don't know.
So now, and when we install it, it'll install it in the up directory, which you have permission to. And then you point it to that area. And that should do it. Let's see if this works. This is fine. Okay, so now it's put in the Python values. Warnings, but no fatal errors yet. Okay. And then, yeah. When I do make J, sometimes I do make, just make sure that. Install. Opt. Well, that's read-only file system. Let's see. In. Oh.
This is.
Oh,
But if I have here. Right.
yeah, so, so can I,
You know what I want? Like if I have a PDF. But more than. What's the count?
so let's see, so do you have Jupyter and Python on this?
Don't have that.
So I'll just,
But I tried. Oh, here. That's good.
then. So.
기다려서. 폴더 두 개를 분명히 두개 차이가 있거든요.
CDI.
이 친구는 사실 잘 모르겠어요. 이두 개는
So we went to,
이두 개는
I understand how.
22거죠.
Yeah. Let me see. Wait. So there we go.
It's amazing to know I have two, we talk.
Let's make it up here. And then let's- How do I get back to?
영점을 나온 거예요.
I'm gonna go back to the OHA.
이것도 영점이 낮을 거예요. 그래도 그냥
So I was in,
점점
I
줄어.
was in,
X가 커졌어. 네, 아무래도 실업급시 X 센스티브한 그런 것 같은데 잘 모르겠어요. 그래서 별로 0.2요? 그쵸. 좀
right? And, okay, all right, so let's see. Oops. Let me make director.
비만 비만 이비 이게 아니야. 이게 근데 이거 아니에요. 좀 헷갈리는 게요. 여기서 1이 저 1이잖아요. 첫 번째가 아니라 지금 이렇게 2를
So let's,
그러니까 1을 넣으면 제가 1을 넣으면 1이 줄어요. 3이 오케이 헷갈리시네.
let's. This. Sorry. Sorry. So we want that with the opt. Yeah, thing with. Instead of the OHA. And get rid of the OHA and make that opt. No. Delete the OHA.
I mean.
OPT. Yeah. So now it will install it in that directory. And then if you can see that directory, you should be able to do it. And this shouldn't take too long because we've already compiled most of it. So we.
But I mean, we did.
방금 보면
So
이거 근데 퍼미시 된거 같아요.
I really thought it was gonna go.
Since I just don't, I'm not used to this one, yes. It should work.
If it can read it.
Fine,
So now we can make.
And I'm really good at.
You repeated it.
Yes, just.
Yeah, but more like maybe this kind of part is
Just
more
extra.
fine.
Well, just, because when you do multiple threads, sometimes they're dependent and it's. Yeah, I don't know if it,
They will try.
yeah, it doesn't hurt.
This kind of part. But like, I can see this kind of part, but I never think about what it's. This is heroin. And I thought that this.
Says to run that. Can we just try it? Oh, sorry, wait, it's not quite done yet. Okay, it's done. So yeah, let's see what that looks.
Do we need?
The,
If we don't have errors.
Oh, I should find a paper that has all like. No problem, I can just try it out. See which one.
We can add to that. Oh, it doesn't, right now it doesn't have a PDF directory. Okay. So you want to see, so if you can link to that opt area.
like I have this. This,
And you can use the OS commands to look at directories that kind of understand.
Yeah.
86.
So that's
28, yeah. So it's a little hard to tell, but I think it's roughly, the red one is roughly right?
yeah.
So 10 to -3,
Yeah,
and so they don't actually have any.
it depends which.
About
it depends
5,
which
so I
sets.
think it's roughly right.
Some of the sets.
This is by something, the red one is by something.
The discontinuity comes next to the order. So you need to set it 2 weeks. And then they have to properly take care of the differences. So I think here we move.
I did.
Yeah, that's, I mean, it's not for.
Yeah, we are using NPDF. And
Equation
you'd have to pull that. But if you get.
arch
you know,
square
If NLO,
times
NLO it is continuous, but not the difference.
is what the steps.
The threshold.
Right.
The two,
And
well,
what's-
probably
what's
work
the
out
concern
right.
is-
Yeah.
But this right is I'll go back to vision.
I don't think you need.
Yeah, there's a point where they go.
That is F2 gamma,
I mean,
right? So I guess. That mean that it's also like. But yeah, okay.
there's a point where.
Okay, so I don't have.
um,
Maybe we only
that's-
want
that's-
to, yeah,
that's-
because this one, the blue one. Is something. This morning, they were driving. Like,
Here, yes. Yeah, so here, when you go across the B threshold, what happens, there's a boundary condition that comes in about this square. And that kicks up the blue on, and it kicks down the bottom quark. And in fact, the bottom quark actually starts negative. And at first glance, you see, wait a minute, I've got a negative PDF. It's probably what's going on. But if you think about it, if you're gonna have discontinuity, it's gotta go one way or the other because you have to preserve the sum.
I was plugging F2 and C.
Some momentum fraction is one, just one up, it's gotta come from somewhere. And it comes from the bottom. Right, now, hopefully anything we calculate will come out positive. Because it's a perturbation expansion. And it quickly goes positive. In fact, if you ran the matching point further back, you go further negative. You get positive. Hopefully, put it together. Right, yeah. It's because as you change, for example, as you change your normalization. You trade just did. There's some extreme point where, you trade one that's so big, you're actually negative. The sum should be positive. And if it isn't, you're on whatever line, you've got to be careful. But, it's unsettling at first, but that's in fact the right answer. And in fact, one of the people who calculated was Jack Smith, who, before he passed away, used to work here. So he worked here with the way the narrative, he was one of the ones who calculated. Thank you. Sure. Yeah.
I don't know what I'm doing wrong. I do X times
Although it could be.
X, X times F, and I'm integrating Simpson that with those X values, and no matter what I'm doing, whatever data set I try like F2, F3, I'm getting like 15%. Yeah, and then, so I also like did the next step without fixing this problem, and this is what the plot was like. Step 4, and this is completely wrong, but it can't be right, I just don't know what's going on.
Right, this is gonna push my.
Yeah.
Let's see, so here. Okay,
I
so,
do X.
so, yeah, so, So zero, that's the. fixed set.
Yeah.
Yeah, we're doing.
Or whatever flavor.
Okay, Q0 is fixed.
I did 3 because that's on the table.
Okay, so you're gonna loop over.
Over all eggs.
Oh, wait a minute. Oh, okay. Okay, I think. All right, let me try it. So this, let me try. The catch is this returns X times F.
Okay, I'm multiplying by x.
Yeah, so I think.
Yeah, just get rid of those
I
x.
think, yeah, but you can do that. I think that's.
See,
Quick checkup, by default, the grids are stored, the PDFs blow up at small x. So by default, the grids are stored as the PDF times x. It flattens it out and makes the interpolation more accurate. So that XF thing means it returns X times the PDF. So, make sure you don't get confused on that, but they're stored internally that way because it's more accurate and the interpolation is more accurate. So that's a cause of quite a bit of confusion and errors. On the way.
okay, so I got 90%.
Okay. So you do count upstream, char bottom.
Bottom and top don't enter yet.
Okay. Do you do the anti-quarks?
No, so how do I access?
So wait.
So I had-
So we do. Yeah, so the flavor goes from, you can just run it from -6, you go 6, and then 0, you still 0.
Okay, wait,
Let me know if it shows.
let me see what the table was.
I think we should be proud.
So it's saying these are like. These are like 7, 8 together. Okay, yeah, that would be like it's 90%.
About 10%.
Okay, thank you. That makes so much more sense. So -6 through -1 are the anti.
Yes, yeah, and I think. In main parse 0 or 21 is okay for the gluon. I think that works. I think it works in OHA.
I'm using, I have an array that has all the numbers, and then I have an array that has their names. And then I just loop over the number array and then use.
Actually, I can check it real.
I
Yeah, I can check it here. Did anyone not sign anyone not get a chance to sign? Yeah, so I just validated, I just verified that in both mathematic and OHA PDF, the gluon can be 0 or 21. So keeps things simple. Oh, so you loaded using the logic. Oh. Let me look. Yeah, it looks like you loaded your PDF here. Oh, yeah, they should be. Let's go back here. So it's So. Okay, so. J,
Like,
um,
5%. So. Probably not like 50, 46. Yeah.
so
That's,
yeah, I
uh,
think what
what
we
you-
want to do. So the 000 is the central. And then the 001 and 2, those are air PDFs. So what we want to do is we want to know the whole thing at a time. So let me remember the. You remember. So. Yeah, so the info file and family up, PDF family parse. That will. It's all the data files. That's what. Okay, so. So what I'm going to do is. So let me try that. PDF family parse. Then. This is. My piece, oh, yeah, okay. All right, so what I'm gonna do is I'm gonna. See, so I use the. Path. Oh, so it's, sorry, it's. It's this, yeah, this one has more, this one, yeah, the proton. Is kind of weird, the proton, we don't have error sense for that. So it's only. So it's 20882, I think that. Okay, oh, so, yeah, I see. So what we just did was, yeah, and let me do a, let me come up here, I'm gonna do a PDF reset. That'll clear everything. Okay, and then we come down here and, so we're gonna do this, that'll automatically read all three. Yeah, and then that's a central value, and I only, to save space, I only put in two. I put a central value in two eigenvalues, but the whole thing has 19 times 2 38 eigenvalues, yeah. Right, so. It's somewhere, and I guess we'll have to go back and. Yeah. So the, yeah, that way it reads in the whole family. And then, you can refer to them by set 1, 2, 3. Yeah.
So with everything, yeah, it's 99.2 here.
Oh, very nice.
99.3,
Yeah.
and then this looks good and it makes sense.
Okay, cool.
Yeah, it was just the anti.
Yes, yeah. No, and then it's kind of fun. You can see,
But
you
this,
see,
the thing
uh,
about
yeah,
this
let's
is
see, it's up is twice the
you
down.
only have me.
One's dominating, and these are coming up.
Yeah,
And,
I put basically twice as much data as I
Yeah.
should in this one.
yeah. But, I mean, it's sort of instructive to see the whole thing,
Yeah.
you see the heavy quarks turning off. Yeah, so. Oh, yes. So that's, let's see, this is the, must be the bottom of the chart. And the strange probably, yeah. Right, it's a draw. Yeah. Yeah, so you can, yeah, these are actually turning on, this is about 1.5, that's. Zero, it's 1, 2, 3, 4.5. Wow, perfect. Yeah, it turns all right at mass. Yeah. Cool. Hi.
When you turn on the like heavy part values after the threshold energy, like in this one. Okay, I think. Like on Thursday, I also heard about the intrinsic heavy part.
Yeah,
I'm not.
I have not put in any intrinsic. So if I had intrinsic, in this case, bottom end the charm, when you go below the mass, they drop out. And if I had intrinsic, then they would stay finite. Well, max. They'd be small, but they, and so, yeah, these assume they drop to zero at the mass.
So. Because we have to. Goes through the threshold value.
The discontinuity only comes in 2 loops, so you would, on none of these, I don't think any of these sets, the N and PDF set and MSHT are 2 loops. So you need a 2 loop set where they've properly implemented the thresholds. That gives you the discontinuity, and it's really small. If you look in the paper, you'll see I had to zoom in. You have to know where it happens, and you have to zoom in, or you don't see it. But it's there, it's physical. And what's neat is the PDFs aren't physical. So you have a discontinuity in PDFs, a discontinuity alpha S, but the physical cross section, any discontinuity you have had better be order alpha S the n plus 1. And that should, as you go higher and higher, that had better decrease, or you've got something in physical. And that's one of the neat things about QCD is that it actually works and all these things conspire to do that. So it's kind of cool.
Right. So they also have the discontinuity in the mesh kernel.
Yeah. So, yeah. And I was just saying, one of the people that calculated was Jack Smith and Willie Van Nerven. Jack Smith used to be here. He passed away about 10 years ago, but he was actually working with George doing it here. So yeah, they were the first ones that did the 2 loop and figured out the discontinuity. So yeah, it's counterintuitive because you have discontinuities in alpha S, discontinuities in PDF, but in the end, the cross section, cross section will have blips, but as you go order by order, they decrease. That's kind of cool. That's looking good, yeah. Very nice, yeah. Yeah, so you have a glow one up and down, or about 2 to 1. And then the C quarks, you've got the B quark and the charm quark turning on. And you see they sort of approaching at some point you get, in principle, you get to an issue 6 limit where all the anti-quarks Are you able to see that directory or no?
Right,
Oh,
it
okay.
doesn't.
So,
So it's here.
I mean, can you do a directory?
Right. Just read it. This is inside. Maybe it's not. I could write inside the file to create Python. I don't.
And you don't have that?
I've never used.
Okay. So if you get to something where you can compile it locally, then the principle should work. I mean, do you want to apply on this one? You're
No,
welcome
it's
to.
okay. That's fine.
You're welcome to. If you-
Yeah, I mean, I would prefer more to know how it works.
Well, I mean, it's sure.
Okay.
So this is a toy version, so do whatever. So basically, I think everything's fine, but if you go down there, you get. Yeah, so go up a little bit. So this is where. Yeah, so XF0 is ours fixed. It's ours free. And those, basically, those are the functions. And once you have those, in principle, once you have those functions, that's what you need, and then you can do it. So. Oh. Make one. Yeah. So if you're having fun with it, keep going. If you're saturated, feel free to quit. If you have questions, we can talk about it tonight. But again, hopefully if these are useful, if you find you need to look at these or do some simple things. And again, once you've done those momentum fractions, you drop in a leading order cross section, you can generate cross sections, F2s, anything like that very easily. So whether it's in Python or Mathematica, so have fun. Well, so you go from -5 to 5. And 21 is 0. So they're 13 if you don't count the top. Or sorry, they're 13 if you do count the top, 11 if you don't. Yeah, so.
That's minus.
You can see why I like going to 0, because I can just go down. I just go loop -5 to 5. Pick up 0 to the ones that do. If anybody gets a good, Python answer for the plots, I'll take that because my Python is weaker than my Mathematica. And if somebody has an elegant solution, I wouldn't mind seeing what that looks like.
You want me to send you?
Yeah, just, yeah.
I'll email when I get to the.
Okay, great. Okay.
All 4 parts?
Sure. Yeah, or just zip the whole Python.
I just started coding randomly in the middle of the notebook. So
That's fine.
I'll move it to the bottom.